Why does the quantum world look like a dice game even when the math looks perfectly lawful? In the energy filament theory, the randomness is what you get when you read a C-state report of the energy C, instead of trying to imagine tiny billiard balls with pre-written trajectories. Season 9 starts with a deliberate refusal. We're not opening with formulas, because if the picture in your head is wrong, formulas only help you memorize the wrong picture faster. Picture an actual ocean. You don't track every molecule of water. You track currents, swells, wind direction, and warning zones. Because those few indicators are enough to predict which routes are stable and which are dangerous. Quantum behavior is the same kind of navigation problem. If you insist that the universe is mostly empty space and things are little points moving through nothing, then every experiment will feel like a magic trick. How can a point interfere, tunnel, or be in two places? But if you start from the core premise that vacuum is not empty, that space is a continuous energy sea, then the first questions become practical. What kinds of structures can exist in this sea? How do they travel, and what kind of map tells you where a transaction can actually complete? In this picture, a matter particle is not a point, it is a stable energy filament drawn out of the sea. A self-sustaining organization that can keep its identity. Light is different. It is a traveling disturbance. A wave packet riding the sea through relay propagation. Not a tiny bead flying through emptiness. Now the famous symbol stops being mystical. It is not a ghostly cloud that an object is made of. And it is not a fog of indecision floating around your detector. It is a compact statistical chart of local sea conditions, how tight the region is, how aligned the texture is, how long the neighborhood can stay in step. So you can forecast where a closure event is easy and where it is hard. That one shift explains why probability shows up immediately. You are not predicting a hidden, fully detailed itinerary. You are predicting which outcomes are easiest to lock in when the sea meets a boundary you built. That's also why different measurements give different answers. Changing the instrument is not just asking a new question. It is laying down a new boundary condition, which reshapes the sea state you are sampling. Even uncertainty reads differently here. It's not nature being coy. It's the cost of resolution. If you want a sharper answer, you must build a sharper gate. And sharper gates squeeze and rewrite the sea more aggressively. That's exactly what happens when you try to demand both perfect positioning and perfect momentum. You are demanding two incompatible gate designs at once. And once you see boundary and threshold as the key words, the second half of the mystery dissolves. Why do waves turn into dots? Because dots are not little pellets showing their true nature. Dots are threshold events. A packet has to form at the source under a formation threshold, and it has to complete at the detector under a closure threshold. Those endpoints are discrete, then if the travel between them follows wave rules. Think of a camera sensor in a dark room. The incoming light can be spread out as a smooth exposure pattern, but each pixel still clicks only when its local threshold is crossed, and the click is a yes or no event. Between source and screen, the sea can carry a smooth interaction-ready pattern. At the screen, the story becomes a discrete closure. Now measurement stops being spooky too. A measurement is not stealing a secret without touching anything. It is physical coupling. You bring in a device, you impose a boundary condition, you press the sea with a ruler, and the sea state you are reading changes because the sea is real. So the season's main line can be said in plain language: draw the sea chart first, then talk about probability. Build the thresholds first, then you get the dots. Next episode, we'll take the double slit and ask a sharper question than wave or particle. What exactly do two slits change in the sea state map? Tap follow, share it on New Physics, Clear Universe.